In the last lesson, I talked about some natural causes of climate change, whether it be global warming or global cooling or whatever, just some kind of more natural causes. In this lesson, we're going to talk about global warming where humans might be a factor or humans might influence. And pretty much we always talk about the greenhouse effect. So yes, global warming, but really we're talking about the greenhouse effect. So before I go into what the greenhouse effect is, let's just look at a little bit of the reason why a lot of scientists think that humans are a factor in global warming. So you see a couple different charts that I have up here. First chart shows the red is the temperature, okay, so degrees Celsius temperature from about the year 1000 to year 2000. And you see it fluctuates up and down, up and down, up and down, but the recent trend is definitely a global warming, okay, an increase in temperature. That corresponds fairly nicely to carbon dioxide level. So there's parts per million carbon dioxide level in the atmosphere. And you can see that it rises about the same time as the temperature rises. Another chart showing pretty much the same thing. Okay, this is showing kind of this area though zoomed in. So we see carbon dioxide levels increase, and so does the temperature increase. There's a pretty good correlation. This one down here doesn't show just carbon dioxide because there are other greenhouse gases. We're going to get to those in a second. Carbon dioxide, methane, nitrous oxide, N2O. So you see again, same kind of thing. All of these are on the rise just as the global temperature is on the rise too. So this is why a lot of scientists, a lot of people think that humans are one of the causes of global warming. So let's go over what this greenhouse effect is. So how do these gases, methane, carbon dioxide, how do those greenhouse gases cause global warming? It's the greenhouse effect. So I'm first going to start with a very simple picture of how the greenhouse effect works. And I'm going to start with a greenhouse. So I'm just going to draw a greenhouse. So there's the ground. There's the greenhouse. And maybe there's some plants in there. So there's a palm tree in there. It's a big greenhouse. Okay. Why does the greenhouse get warm? Well, the sun gives off light. So here's the sun. The sun gives off light, it gives off lots of radiation. Remember we talked about our electromagnetic spectrum? The sun gives off lots of radiation. The radiation that we're concerned with for this is shortwave radiation. Okay, so the sun emits shortwave radiation. Shortwave radiation, UV, visible, the short infrared. Okay, so the infrared is one of the big ones, but it's all the short wavelengths. What happens to the shortwave radiation when it hits the glass of the greenhouse? Not much. It goes right through. So the shortwave radiation goes through and it hits the trees, or it hits the people, or the animals, or the ground, or a table, or it hits whatever's in the greenhouse and gets absorbed. So the things in the greenhouse absorb the shortwave radiation. When they absorb it, they get hot. So they're going to re-emit the shortwave radiation as long-wave radiation, otherwise known as heat. So I'm going to draw some long waves. So now they emit this long-wave radiation and heat. That heat cannot escape the greenhouse. So it kind of bounces around, and the greenhouse gets warmer and warmer and warmer as more shortwave energy comes in, and the long wave or the heat cannot get out. So the greenhouse gets warmer. Same kind of thing happens with your car. Okay, you know your car in the summertime. Here's your car. Let's do a fancy station wagon. Beautiful car. So you have your seats on the inside here. The sunlight comes in. Shortwave comes through the windshield, heats up your seats. You come back, you come out of the mall from doing your shopping. You open the door of your car and it's like 140 degrees inside or 150 degrees inside. because the heat was trapped, the shortwave went through the windows, it was absorbed by the interior, changed to long wave, which couldn't escape, and it got hotter and hotter in your car. Some people leave the windows cracked open to try to get some of the heat out. Some people have the reflective thing that they put in the windshield to try to keep the sunlight out. Um, it can be a big issue. Your car gets really hot. One of the things you want to make sure of is you never leave a child or a pet in the car. The temperature can rise very, very quickly to where a pet or a child couldn't survive. It raises their body temperature up and they die. And you hear cases of this every summer. You get 6 or 7 kids are left in a van or left in a car, and the temperature gets too high and they die. It's a horrible situation. Okay, so kind of as you get older, make sure that you never ever leave a kid or a pet in a car alone. Okay, it can get really, really hot. So how does this work for the Earth? So we saw it with a greenhouse, we saw it with a car. How does this work for the Earth? So let me draw a quick picture of the Earth. And really, I'm just going to draw part of the Earth. So here's the Earth. Going around the Earth is the atmosphere. So I'm going to draw a greatly exaggerated atmosphere. So there's the atmosphere here, way bigger than to scale it would be. We have the sun shining. So the sun's up here shining, emitting all sorts of radiation. Again, the radiation that we're concerned with is the shortwave. So let me draw this in, and you can draw this on your sheet too, so you should be drawing a picture of this. If you drew a picture of the other ones, great. You didn't necessarily have to, but definitely draw a picture of this one, and go ahead and label it greenhouse effect. And then let's write down here. So we said sun emits shortwave radiation. So sun emits shortwave radiation. What happens when that shortwave radiation gets to the Earth's atmosphere? Well, just like the greenhouse, it goes right through. So draw it going right through, and then write that down. I'm going to do abbreviation SW, so shortwave radiation goes through atmosphere. Shortwave radiation goes through atmosphere. What happens when the shortwave radiation hits the Earth, or people, or cows, or plants, or whatever? So what happens when it hits the Earth? It gets absorbed. So down here I'm going to write down shortwave radiation gets absorbed by Earth. And what happens to it once it gets absorbed? Well, that energy is going to be, so I can say, and re-emitted. The energy is re-emitted as long wave. And I'm going to put long wave slash heat slash infrared. All basically mean the same thing. Heat. Infrared is what that says. Okay. So the shortwave gets absorbed by the Earth, and that energy is re-emitted as long wave radiation heat. So now I have my long wave radiation. What happens to it in the atmosphere? Okay. I'm going to write up here, long wave radiation cannot escape atmosphere a lot to write. So long-wave radiation cannot escape atmosphere because of greenhouse gases. So, Earth warms. The Earth gets warmer and warmer. Now, is this always a bad thing? No. We need the greenhouse effect to survive. If we didn't have the greenhouse effect, we would freeze at night. Okay, the atmosphere traps in the heat from the daytime. So greenhouse effect is good. Too much of the greenhouse effect is bad. Think of the planet Venus. Really thick atmosphere, traps in all the heat. So even though most of the sun's energy is reflected off the thick clouds, some of the energy gets through, is absorbed by the planet Venus, all that heat is kept in, and it's incredibly hot on Venus. Hot enough to melt lead. Always. Daytime, nighttime, summer, winter, it's always hot. So that's kind of like the greenhouse effect gone wild. We don't want that on Earth. We want the greenhouse effect, but we don't want it to increase. We don't want the Earth to get any warmer than it is. What are some of these greenhouse gases? We said the long wave of the heat can't escape the atmosphere because of greenhouse gases. What are some of these greenhouse gases? Water vapors, one of them. The ones we're mostly concerned with, though, for the human ones, we're mostly concerned with CO2 and with methane. So those are the ones that we're mostly concerned with when we're talking about humans causing global warming. So what are some causes then of this greenhouse effect? So where are these gases coming from? I guess I don't really have it on this slide yet. So where's this CO2, this methane, this NO2, where is this coming from? A lot of it's just pollution, burning of fossil fuels. So oil, gas, natural gas, okay, burning of that puts a lot of carbon dioxide into the atmosphere. Deforestation. It's cutting down trees or cutting down plants that would absorb the carbon dioxide from the atmosphere and take it out of it. A lot of people say cows. Cows are causing global warming. How? Yes, they are, because yes, they are a factor. Cows belch methane. Okay, so this big one here, methane. And methane is a lot stronger greenhouse gas than CO2 is. Okay, methane is a very powerful greenhouse gas. So cows belch methane. And they actually belch a lot of methane. So that is where that might come from. So those are some of the causes of these greenhouse gases for the greenhouse effect. Now let's get to some of the results of it. And we see some potential climate changes. One of the ones that really worries me is this first one, the health one. Weather-related mortality, infectious diseases. Okay, that's one of the big things with me. As we get a warmer planet, there are lots of diseases that can flourish. Or insects that carry diseases suddenly aren't killed during the winter. Or they can spread away from where they live near the equator. Okay, so that's kind of one of the big ones for me. Yes, things like flooding from water's levels rising, is bad. Stuff like that. The disease one really scares me. Agriculture. Okay, crop yields are going to go down. You kind of think the crop zones are going to shift, where we can grow rice or where we can grow corn. When the earth warms, those crop zones are going to shift, and they start shifting to latitudes where we don't have enough land to grow those crops. It's going to change the forest composition and other vegetation things. Water supply is going to get a lot harder to come by. There's going to be more competition for water. Have more erosion, water levels rise, and lots of extinctions and things like that because the habitats are changing. You always hear about things like the polar bears and stuff like that. Maybe that's a little overblown example, but it's a very good example just to kind of think of, is that if they don't have the ice there, they can't go out on it and do their fishing and survive that way. Okay, so there's some results. Other results, things like hurricanes, okay, or weather. Weather gets more severe. When we're looking at hurricanes, a lot of scientists think that it's not going to be necessarily more hurricanes. Okay, you can see this number of occurrences. The black is with a higher CO2, so this is a higher CO2 level. Okay, so not necessarily more hurricanes, but the hurricanes that we have are going to be stronger. Um, this down here just shows you carbon dioxide level rising, just showing you the seasonal rise and fall of carbon dioxide level in the atmosphere because of basically summer, winter. This is indicators of a warming world. So how do we know that this is happening? Okay, what are some signs that the Earth is warming? Well, increase in humidity, temperature over the oceans warming, sea surface temperature warming, sea ice level decreasing, ocean getting warmer, sea level rising, glaciers getting down, so cover. Okay, so you can see some of these just different indicators. So then the last thing, what can we do? And I like this little concept map, and it really, kind of goes over. You can pause if you really want to look at it more. But I like that it splits it out into, okay, travel. How can I help things with my travel? Okay, at home, how can I help things? When I'm eating, how can I help things? Um, Being a catalyst. Just different things. What if I'm traveling? Best travel. Okay, I ride my bike. I can walk. Use public transportation. Those are better than air travel. I can switch to green power. Okay, at home, I can use energy efficient light bulbs like LEDs instead of incandescent ones. I can choose energy efficient appliances. I can maybe hang my clothes out instead of using the dryer as much. I can eat less meat because they're belching methane. So you see them belching the methane. I can use a cloth bag instead of a plastic bag. So there's lots of different solutions. And there's, of course, a lot more, and you can search and find a lot of great ideas. I just like this kind of simple idea. Um, and like I said, scientists pretty much are agreed now that humans are definitely one of the factors for global warming. If you still disagree with that, and there are a lot of people that do disagree with that, whether we're the cause or not, we don't want global warming. Okay, all those things I just talked about, we don't want global warming. So whether we're the cause or not, doing some of these things may help at least slow global warming. I said whether we're doing it or not, you can at least slow it because we do not want global warming. It will not be good for us.